Okay, so now 1 over x domain. Okay, and also approach to negative infinity. So sketch the graph of rational function involve vertical and horizontal asymptote. So x approaching to 0 from right. X approaching to 0 from right. X menghampiri 0 dari sebelah kanan. X approaching to 0 from right. X, and then fx approaching to positive means that x approach to 0 from right. Okay, from right here. And then the value of y is getting bigger and bigger. So same thing goes to x approaching to negative infinity, then fx or y approaching to negative infinity, dia semakin kecil ke bawah. So this one here now, and we sambungkan this graph. Okay, you get something like this. Okay, so class, at this moment, for this example, x-axis is where the value of y equal to 0. Y-axis is also where the value of x equal to 0. So in this point here now, y equal to 0 or x-axis is the horizontal asymptote of the graph. And y-axis or x equal to 0 is the vertical asymptote of the graph when x approaching to 0 from right and left. Okay, so find the vertical and horizontal asymptote of fx1 over x squared, where x cannot be equal to 0, as we know that the denominator x squared cannot be equal to 0, so then x cannot be equal to 0, meaning that the graph won't touch the y-axis at all. But the thing is, when we have 1 over x squared, ada yang baru masuk ke ni? Okay. Sketch the graph. So class, for this one here now, okay, let's say when x equal to 1, 2, 3, 1, negative 1, negative 2, and negative 3. So 1 over x squared, 1 over 2 squared equal to 1 over 4, which is 0.25. 1 over 1 square, which is 1. Okay, 1 over 3 square, 1 over 9. Okay, 1 over 9, please get, we call the value in decimal for me. 1 over 9. But it's getting, we call the numbers is getting smaller and smaller. I think so. 1 divided by 9, 0.1111. Okay, so for this is 0.111. Okay, this one supposedly above here. So when x equal to 1, 1 over 1 squared is 1. When x equal to 2, 2 squared equal to 4, 0.25, and then 0.11. But then when it comes to 1 over 0.5 square, which is 1 over 0.25, or 0.12, 1 over 0.25 is 4, I think so. Am I right?
Yeah.
Correct? Okay. This was equal to 1 divided by 0.25 is equal to. So when x is 0.25, y equal to 4. So this is the graph. Okay, the graph moving up. Okay, and then when we have x negative 1, negative 2, negative 3. So just imagine that negative 2 square, negative 2 square, you will get 1 over 4. Negative 1 square, 1 over 1 is 1. Negative 3 square. So negative 3 square equal to 9. So you will get 1 over 9. So you will get the same, exactly the same as this one here. Negative 0.5 square is 0.25, which is 4. The graph will be something like this. Okay, when x approach to positive infinity from left, the graph y, we call value of y, is moving up, approach to positive infinity. So then x approaching to 0 from left and right, then the graph is moving up. So vertical asymptote is just like, okay, it's just like when we substitute the value of x equal to 0 from left. Okay, class, for this one, actually, that if we just imagine this is negative 1. So approaching to x from 0, we just imagine it's not that we substitute the value of negative 0.5 into the function. Okay, we just imagine that if we substitute negative 0.5 squared into the function, it is 0.25. Then you get the positive here, and the result is 1 over is equal to 4, which is positive infinity. So substitute the value is just for us to imagine it, but then the result is whether positive or negative infinity. So then just like this, when x approaching to 0, we call infinity. Okay, when x approaching to 0 from right, x approaching to 0 from right, from 1 to 3. So from 3 to 2, 2 to 1, 1 to 0 0.5, 0 0.4, 0 0.3, 0 0.2, 0 0.1, 0 0.11, very close. So once we start trying to substitute into this function, 1 divided by 0 0.11 square. 0 0.11 square. 0.11 times 0.11 is 0.011. 1 divided by 0.011, 82.64, 82 something, which is a big number of positive infinity. So then, when x is getting close to x equal to 0 from right, the value of y, dia kalau bahasa Melayu kita naik mencanak, okay, to a big numbers of y. This is a value of y actually. So then, if we sketch the graph and we make a line here, so you will get one complete line, one complete graph of something like this. Okay, and also this one here now, something like that. Okay, saya bila dengar bunyi ting tong orang masuk tu saya risau. Dia guna email MOE ke email personal yang mengganggu sebenarnya ni. Someone wants to call, join this call yang gunakan email personal ini yang mengganggu sebenarnya. Tapi dah cakap berkali-kali, susah nak faham, tak tahulah. Okay. Okay, so now, what about this? Okay, so 1 over x squared plus 5x minus 6. Class, as we know that the denominator, this cannot be equal to 0. So x squared plus 5x minus 6 cannot be equal to 0. Factorize. Okay, so we got x and x. This one, which I think that is the suitable one, is 1 and 6 with positive and negative. Let's try again. X times x, x squared. X times 6, 6x. X times negative 1 minus x. So 6x minus x, 5x. Negative 1 times 6 equal to negative 6. That's it. So it means that here now, x cannot be equal to, sorry, x cannot be equal to 1 and x cannot be equal to -6. So class, if you if you found that the value of x, the denominator that cannot be equal to 0, x cannot be equal to this and this, automatically, secara automatically it tells us that this is the vertical asymptote of the graph. Okay, so then x cannot be equal to -6 and x cannot be equal to 1. Okay, and I said that just now, automatically this is your vertical asymptote. So something like this: when there's a graph of x and y-axis here, x -6, x equal to -6, and x equal to 1, x equal to 1. So the graph will be something like this: when x approaching to -6 from left and approaching to -6 from right, approaching to 1 from left, approaching to 1 from right, we are going to find the behavior of the graph is whether moving up or moving down. Here, moving up or moving down, up, down, or up and down. We need to find out. Okay. But then the domain is also telling us this: x cannot be equal to -1, x cannot be equal to -6. So this is the domain. Now, okay, so this is the one that we're gonna find out. Okay, if I just use this we call this page. Okay, if I just use this page to explain everything. Okay, class, I'm going to explain by writing the example of this. X equal to -6 and x equal to 1. Ada lagi. Okay, so now class, when x approaching, okay, okay, limit of x approaching to -6 from left, 1 over x squared plus 5x minus 6. Limit of x approaching to -6 from right, 1 over x squared plus 5x minus 6. Limit of x approaching to 1 from left, 1 over x squared plus 5x minus 6. And limit of x approaching to 1 from right, 1 over x squared plus 5x minus 6. Okay, now class, just imagine 1 over something square plus 5x minus 6. Okay, x approaching to -6 from left. So just imagine that this is -8, -7, from -8 to -7, -7 approaching to -6 from left. -7, -6.5, -6.4, -6.3, -6.2, -6.1, -6.01. Okay, class, tell me if I use the value of -6.01, -6.01. Tell me the result of this. You get a positive or negative value? Class, -6.01 square Plus 5 times negative 6.01 minus 6. What's the result of that? Anyone from the whole class? Please tell me what is the result of this positive or negative infinity? Hello? Are you all with me?
Positive infinity or negative
Positive infinity.
infinity?
Positive infinity. Okay. Give me the accurate value of that. Nilai dia apa nilai dia? Come on, one of you.
Negative infinity.
Negative or positive? I heard negative positive just now. Yang mana satu yang betul? Positif ke negatif?
Negative infinity.
Negative infinity. Okay, negative 6.01 and negative 6.0. X square plus 5x minus 6. Kelas, I get positive. Betul ke?
Oh, positive.
Positif or negative?
Positive infinity.
Positive. Okay, positive infinity means that it is positive here. Okay, now, what is the value of x approaching to negative 6 from right? Negative 1, negative 2, negative 3, negative 4, negative 5. Okay, negative 1, negative 2, negative 3, negative 4, negative 5, negative 5.55, negative 5.8, negative 5.9, negative 5.99. Okay, if I choose the value of x, negative 5.99, negative 5.99 and negative 5.99. Okay, let's try together. Okay, class. Can anyone tell me what is the result that you get then? Hello, anyone? So class, come on, one of you.
Negative 14.31.
Okay, negative 14 point something, which is negative. Okay, sorry, negative infinity. Negative infinity. Okay, then limit x approaching to 1 from left. So from negative 1, 0, 1. So negative 2, negative 1, 0, 0.5, 0.8, 0.9, 0.99. Okay, if I substitute with 0.99 here, what do you get?
Negative 14.31.
Negative 14.31. Negative infinity. Okay. And then let's say this is x. Okay, this is x equal to 1 from 4, 3, 2, 4, 3, 3 to 2, 2, 2.1.5, 1.1.1, 1.01. So just imagine that if I substitute with 1.01 here and 1.01.
Positive
Positive
infinity.
infinity.
Positive infinity. 14.26 something. Okay, positive infinity. So class, from this result, 1, 2, 3, 4, can we determine or imagine the graph, how the graph looks like? Okay, let's sketch it together. So x approaching to negative 6 from left is positive infinity, meaning that it is something like this. Okay, sketch the graph with different colors of inks here. Okay, something like this. Okay. When x approaching to negative 6 right, from right, okay, is negative and negative. Might be graph with something like this and this. So just imagine that if y, the graph intersect at y-axis, intersect y means that x equal to 0, x equal to 0, x equal to 0. 0 square plus 50 is 0, and then 1 divided by negative 6. So this is negative 1 over 6. And then when x approaching to 1 from right, x approaching to 1 from right, the graph is positive infinity. Something like this. Okay, so here we go. We have test the value. Okay, in your examination, testing by substitute the graph, or you can substitute the value of x approaching to yang terlalu hampir dengan x tu is just for a rough calculation. But then in your yang kita kira dalam exam is just this step. This is positive, this negative, this negative, this positive. That's all. Okay. So then so then we have negative and positive then. So x approaching to positive and negative infinity, approaching to 0 here. Horizontal asymptote is y equal to 0. Okay. So for this one, for this limit of x approaching to infinity, 1 over x squared divided by x squared over x squared plus 5x divided by x squared minus 6 divided by x squared. Okay, so this is 1. And there we go. This approaching to 0, 0, 0. So it is now is 0 divided by 1 plus 0 minus 0, which is equal to 0. So that's why the horizontal horizontal asymptote is y equal to 0. So then let's take a look at the graph. How the graph looks like. This is the one. Okay, exactly the same that I sketched a draw for you just now. Okay, and then next. Okay, it is x minus 1 divided by x squared minus 1 and x minus x minus 1 divided by x squared minus 1. So sketch the graph of the function for this class. Okay, x squared minus 1 cannot be equal to 0, meaning here it is x minus 1 and x plus 1 cannot be equal to 0. So then x cannot be equal to plus minus 1. Okay. So then here now, okay, so from here we can see clearly that we can just simply cut these two, and finally we simplify this as an actually that this is 1 divided by x plus 1. Okay. Okay. Salin belum? Dah salin, eh? Okay. So now, vertical asymptote. Okay, vertical asymptote and horizontal asymptote. Okay. Okay, so x cannot be equal to negative and positive 1. This is x equal to negative 1 and x equal to 1. Okay. So we're going to find out the limit when x approaching to negative 1 from left and right, left and right. Okay, so limit of this x approaching to negative 1 from left, x minus 1 divided by x squared minus 1, and limit of x approaching to negative 1 from right, x minus 1 divided by x squared minus 1, and then limit of x approaching to 1 from left, x minus 1 divided by x squared minus 1, and then limit of x approaching to 1 from right, x minus 1 divided by x squared minus 1. So again, fx equal to x minus 1 divided by x squared minus 1. Substitute the value of x approaching to negative 1 from left, from negative 3, negative 2, negative 1.5, negative 1.2, negative 1.1, negative 1.01, negative 1.01. Substitute negative of negative 1.01 here into the function. You okay, then you decide whether it's a positive or negative infinity. Okay, so then, so for this one here now, when x approaching to negative 1 from left, substitute the value. Okay, because as we know that y equal to x minus 1 divided by x squared minus 1, we have simplified just now. Okay, x minus 1, x minus 1, and x plus 1. So then clear this 1 over x plus 1. So that's why, okay, yang saya buat tadi, actually that we can simplify this as an 1 over x plus 1. Okay, but then saya sengaja tulis dia secara penuh. Okay, saya tulis dia secara penuh, but then we simplified this one here, 1 over x plus 1 from to negative 1 from left and right here. Okay, look at this one here now. If we substitute the value of x, they're very close, which is x approaching to 1. We substitute 1, 1 over 2, and 1 over 2 here. So x equal to 1 is not the vertical asymptote. X equal to 1 is not the vertical asymptote. And then for horizontal asymptote, here, okay, so then substitute the value of x equal to, we call, when x is getting bigger, positive or negative infinity is 1 over infinity. So then it is equal to 0. Okay, so just imagine that if x equal to 2, 5, 10, 50, 100, so on, plus with 1 is a big number. 1 over big number is 1 over infinity. So 1 over big number is approaching to 0. So horizontal asymptote is y equal to 0 here. Okay, so you may substitute into any maths apps just to find out, just to make sure whether your graph is correct or not. And as we know that just now, this one, limit x approaching to positive 1 from negative to positive here, the value is 1 over 2. So actually that for this graph, there's value, okay, there's value of y, then y equal to 1 over 2. So there is no asymptote here except for this one when x equal to -1. Okay, so then the vertical asymptote is y x equal to 1, -1, and horizontal asymptote. Horizontal asymptote, the graph berterusan. Okay, the graph terus ke sebelah kiri dan kanan, approaching to the y equal to 0, but it won't touch the x-axis at all. So what about this? Determine the asymptote of this. Okay, class. First of all, for this kind of the function, we notice that square root of x squared minus 4 cannot be equal to 0. Okay, we need to consider two things here. The first is the whole denominator. Okay, the whole denominator cannot be equal to 0. And then x squared minus 4 inside this cannot be equal to negative value. Cannot be equal to negative value. X squared minus 4 cannot be equal to negative value because square root of negative and the whole function is undefined. So we take the first condition, this one cannot be equal to 0, and x squared minus 4 cannot be less than 0. So then x squared minus 4 must greater than 0. So with these two conditions here, meaning that x squared minus 4 is greater than 0 only. Okay, not equal. So then for this one here now, for x squared minus 4 greater than 0, then x minus 2 and x plus 2 greater than 0. So x greater than -2 and x greater than 2, greater than and greater than, we have negative, 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 positive, positive, positive. We get positive, negative, positive. Okay, so then as we know that x squared minus 4 greater than 0. So greater than 0, we take the positive value here, which is the domain of this function. The domain of this function is negative infinity until -2, union 2 to positive infinity. Okay, class, when we discover this, when we found this, the domain of this function is this the one. Okay, so what is the function just now? 2 divided by square root of x squared minus 4. Okay, fx equal to 2 divided by square root of x squared minus 4. So the domain of this function is negative infinity until -2, union 2 to positive infinity. Sorry. Lah, bengkok juga. Sorry. Okay. So we got -2 here and x equal to 2. So class, the domain is from negative infinity until 2, which means that on this side here, this is where negative infinity until -2, this part, and 2 to positive infinity, 2 to positive infinity. So what about this space? Is there any graph in this function, in this area? Class, do we have any graph in this area? Yes or no? Class,
Sir,
Class, yeah. Do you have any graph in this area? Yes or no?
No.
No. Okay, why? Because the domain is just this part here, negative infinity until 2, negative infinity until 2, and 2 to positive infinity means that there ada vacuum di tengah-tengah ni. Okay, so then we found that the limit of x approaching to negative 2, x approaching to negative 2 from left. So 2 divided by square root of x squared minus 4 and limit x approaching to 2 from right. 2 divided by square root of x squared minus 4. So from negative 4, negative 3, negative 4, negative 3, negative 2.5, negative 2.2, negative 2.1, negative 2.01. So just imagine that if I substitute with negative 2.01 here with this x, okay, 2 divided by square root of x squared minus 4. Substitute here with negative 2.01. Okay, somebody tell me what is the result of this, positive or negative infinity?
positive,
Positive or negative?
positive,
Pardon? Positive.
positive,
Positive infinity.
positive, sir.
Okay, when x approaching to 2 from right, then we have 4, 3, 4, 3, 2.5, 2.2, 2.1, 2.01. So substitute with 2.01 here. Come on, positive or negative? Class x equal to
Positive,
2.01.
positive two,
Pardon?
positive two,
Positive? Positive 2. Okay, positive 2 point whatever that. I wanted the result positive or negative. So class, please refer to your smartphone. Please refer to your smartphone. So when key in the function of y equal to 2 divided by square root of x squared minus 4, and then vertical asymptote of x equal to negative 2 and x equal to 2, then the graph, this is a graph. There is no graph in between. Why? Because the domain we have stated here from negative infinity until negative 2, negative infinity until negative 2, and 2 to positive infinity. That's it. Okay, saya kena padam lah kot. Yang lain conteng sebab nak tengok apa yang nota keluar tu. Tapi it's okay because I recorded our session here now. Then saya akan kongsi balik video perbincangan kita ni termasuk yang semalam melalui WhatsApp kemudian. Okay. Okay, bila saya dah dah record, senang. Mana you all boleh tengok balik semula bila-bila masa nanti. Okay, positif yang positif, vertical asymptote. Okay, for this one, horizontal asymptote equal to 0. That's it. So that is the one. Okay. Okay, determine asymptote of apa function saya macam terbenam sikit. Sketch the graph of the function. Class, what is the function of this? Oh, ln x. Okay, limit of ln x. Okay, as we know that the function of ln x, this is the graph. Okay, y equal to ln x. So when x approaching to positive infinity, the graph is getting bigger. And when x approaching to 0 from right, the graph sliding down. Okay, look at this. When x approaching to 0 from right, x approaching to 0 from right, the graph sliding down, approaching to negative infinity. Sorry, negative infinity. And then x equal to 0 vertical asymptote. So that is the one. Okay, so that is the movement of the graph. Okay. So that is the movement of the graph. No horizontal asymptote. Okay. And sketch the graph of this function. Apa graph exercise ni? Oh, this class, this is an exercise. So I think that I just leave it this to all of you for you to try as an exercise. And we still have a time, which I think that let's continue with the last final part of this topic.
Cancer.
Okay, so take 5. You all nak pergi minum ke, nak apa ke? Ataupun take 3 je kot, tak payah lama sangat. Take 3, you all nak siapkan makanan ke apa minuman ke apa ke? Ataupun nak stretching, because I'm going to continue the last final part of this topic. So by tomorrow, we're going to meet. Okay, we're going to meet again in lecture hall. And let's begin with chapter 9, differentiation. Okay, so right now, take 3. I'm going to make some preparation for the graph of function, for the notes of last final part. Okay, class, we continue with the last final part of this topic. Okay, class. Nampak ke apa yang saya share tadi? Share sekarang. Class, can you see?
Nampak.
Nampak? Okay. So now, so at the end of this topic, students should be able to interpret the continuity at a point C, compute the continuity of function at a point. So class, continuity dalam bahasa Melayu keselanjaran. But then selanjar bahasa istilah matematik might be you're not very familiar with. Okay, every time that we watch a movie and at the end of the movie dia kata to be continued. Have you because seen that word before? Pernah nampak tak ayat tu sebenarnya? To be continued. Class, have you recall see the word of to be continued before?
Yes, sir.
Okay, bermakna dia akan bersambung. Look at the term of bersambung. Okay, so means that here continuity or keselanjaran, meaning that if you can sketch this graph smoothly without kita kata lifting up the pen at any point, and this graph is smoothly, we can sketch something like this. Okay, so we sketch it nicely, something like this. This is continuous at all values of x. Continuous. But then when it comes, okay, this one, what about this? Is it continuous? Class, is this continuous?
Yes.
Yes, this is continuous. Okay. Okay, so what about this? What about this? Is this continuous? Especially at this point. Is this continuous?
No.
No. Okay, look at this. If I begin from here and sketch this. Oh, okay. I'm stop here and then I need to leave a pen and start at this point and continue my journey. So dia ada terputus kat sini. Terputus. It's not continuous here. So this is okay, this is discontinuous. Okay, look at this. This cache. Suddenly stop here and then he lift up the pen. Dia angkat pen tu and then he start at a new point and continuing sketching the graph again. So then this is discontinuous. And also here, okay, at one side and on lift pen and starting again on the other side. This is discontinuous. Okay, what about this one now? Class, is this continuous?
No.
No. Good. Why? Because from here, I sketch the graph smoothly. Suddenly I stop. Then I lift up pen. Saya angkat pen. Then I point a dot here. Then I need to lift a pen again and start the journey from here, continuing on the other side. So at this point, it is continuous, discontinuous. Okay, so this is discontinuous. And of course, I do believe that all of you can guess this. This is also an example of discontinuous. Okay. So definition of fx is continuous and x equal to a if and only if fa is defined, limit fa fx exists, and limit fx equal to fa. Class, we have discussed this before in the topic of limit. Okay, we have discussed this before in the topic of limit. Please refer to the subtopic of limit. Limit means that limit x approaching to a from left of the function fx equal to L, exists equal to L, and limit of x approaching to a from right of the function fx is also equal to L, and the limit of x approaching to a from left of the function fx equal to limit of x approaching to a from right of the function fx, they are equal, then we come up with the conclusion that the limit of x approaching to a of the function fx exists. So ini syarat untuk had. Syarat untuk had, syarat untuk limit. The condition of limit. Please refer to 8.2 if I'm not mistaken then. Okay. So we bring up this condition of limit into this part, addition with these two syarat. The addition tambahan dengan dua syarat ni, fa is defined, and limit of the function fx, limit of this function fx exists and is exactly equal to fa, then we come up with the conclusion that we come up with a conclusion that the function is continuity at the point of x equal to a. Okay. Determine whether the function fx is continuous at x equal to 2. Okay. X equal to -2. Limit x approaching to 2 from left. Y equal to 1. Limit x approaching to 2, -2 from right. Then the value of y equal to 2. Limit of x approaching to -2 from left, fx, limit -2 is 1, and limit x approaching to -2 from right of the function fx equal to 2 here. The limit exists from left exists, the limit from right is also exists, 1 and 2, but then the value of these are not equal. So we come up with the conclusion that the limit of x approaching to -2 of the function fx does not exist. Okay, sebab nilai dia tak sama. Okay, x equal to 2. Okay, limit x approaching to 2 from left and limit x approaching to 2 from right. The value of y is 2 here. Limit of x approaching to 2 from left of the function fx equal to 2. Limit of x approaching to 2 from right of the function fx also equal to 2. And class, look at this. When the function of fx, when the function of fx, x equal to 2, x equal to 2, y is also exactly equal to 2. 1, 2, and 3. Limit x approaching to 2 exists of the function fx exists. The limit of the function fx equal to 2. And when x is exactly equal to 2, y also equal to 2. So class, at this point, the function is continuity. Dia berterusan. Selanjar at x equal to 2. Dia berterusan. Tidak ada apa-apa lubang ataupun yang menghalang perjalanan pen tersebut. Okay. So this is continuous. This is not. X equal to 0 is of course not. But then, what about x equal to 3? Okay. When x approaching to 3 from left, x approaching to 3 from left, x approaching to 3 from right, the value of y, let's say we say this is equal to 3. Limit of x approaching to 3 from left of the function fx equal to 3. limit of x approaching to 3 from right of the function fx is also equal to 3. So then the limit x approaching to 3 of the function fx exists. Let's say now class, x approaching to 3 from left, x approaching to 3 from right. By the way, when x is exactly equal to 3, when x exactly equal to 3, what is the value of y? What is the value of y? When
3.
x exactly equal to this one here. X exactly equal, when x exactly equal to 3, y equal to
2.
equal to 2.
2.
2. So, limit x approaching to 3 from left, dia menghampiri y equal to 3. When x approaching to 3 from right, y also approaching to y equal to 3. But when x exactly equal to 3, y equal to 2. So, this, okay, the first condition dah dipenuhi. This condition, they have a value of y, but then they are not equal. This part is not equal to these two parts here. So, is it continuous or not? My answer is they are not. This is discontinuous. Dia tidak selanjar. Okay, does not exist. A. Okay, class, because this our session is recorded, so you don't have to worry if kalau kamu tertinggal, kamu boleh tengok balik kemudian nanti. Okay, when x equal to 0, positive. Positivity is exists undefined. X, okay, when x is exactly equal to 0, there's, okay, when x is exactly equal to 0, there's no value of y. So then this is called not continuous. Okay, when x equal to 2, look at this, approaching to 2 from left, approaching to 2 from right, 2 and 2. So the limit equal to 2. When x exactly equal to 2, y also equal to 2. So then this is continuous at x equal to 2. Okay, now when x approaching to 3 from left and right, yes, the limit exists equal to 3, the limit exists equal to 3. So then the limit of x approaching to 3 is also 3 here. But then when x exactly equal to 3, then the y equal to 2, not 3 as the one here. So then they are not continuous at x equal to 3. As simple as that. Yang last final part ni, dia sesimpel itu. You just remember, when x approaching to one value from left and right, dia memberikan nilai y yang sama. And when x is exactly equal to that value, dia berikan nilai yang sama ataupun tidak. Kalau sama, is selanjar. If not, is not. Okay, determine the point where the function is not continuous. Determine the point where the function is not continuous. Class. Again, denominator cannot be equal to 0, so then x cannot be equal to 1 and x cannot be equal to -2. Okay, so class, the domain of this function from this, okay, from this to this, and this one, we can come up with a conclusion that the domain is -infinity until -2, union -2 until 1, union 1 to positive infinity. Meaning that all values of x are the domain of this function except when x equal to -2 and x equal to 1. So bermakna at this point and this point, the graph is not continuous. Why? The graph might be something like this, might be something like this. This one, and this one. Mungkin begitu. Okay. So look at this. At this point of x equal to -2, on this left side, the graph moving up. And this one graph moving down. Dia tak bertemu pun. Maknanya tidak bersambungan. So, it is not continuous at x equal to -2, -2 and 1. The fx is not continuous at x equal to 1 and x equal to negative. Sketch the graph of the function and determine the continuity of f. Sorry, x squared plus x squared plus 2x plus 1. X squared plus 2x plus 1. X less than 0. Okay. X plus 1. For x greater than or equal to 0. Okay. Okay. Sketch the graph. Determine the continuity at x equal to 0. Okay, class. If we like to sketch the graph of this and this in full graphical, so we have to sketch the graph of this x squared plus 2x plus 1. Let's see how the graph looks like. Right, 2x squared plus 2x plus 1. Okay. The graph will be something like this. Okay, this is a graph of this this is a graph of x squared plus 2x plus 1. And then x plus 1 when x equal to 0, when x equal to 0, y equal to 1. And when y equal to 0, x equal to -1. Okay. Okay. By the way, class, the domain of this function for x squared plus 2x plus 1, the domain is less than 0. So this is 0, less than 0, and greater than 0. Less than 0 is for x squared plus 2x plus 1, meaning that the graph is just on left side here. And then for this one, x greater than 0 for x plus 1 here. So let's see if we sketch. Okay, we want the graph, exact the graph here, this one and this one. This. Okay, class. This is graphically. Secara graph, jika saya tunjukkan for x greater than 0, the function of x squared plus 2x plus 1, this is the graph. And for x greater than 0, x plus 1 equal to 1 to positive infinity. Which I think that the graph of this class, when x equal to 0, I make a mistake here, sorry. It's supposedly something like this. Dia bersambung. Okay. Okay. So this is a graph. Now, class. Okay. This is by graphically. So you can see the graph something like this. Okay, now let's try with a limit of x approaching to 0 from left. Okay. X less than 0 and x greater than 0. Okay, for x less than 0, the function is x squared plus 2x plus 1. And for x greater than 0, it is x plus 1. So now class, x approaching to 0 from left. Which function that we're talking about then? X squared plus 2x plus 1 or x plus 1? Okay, anyone? If x approaching to 0 from left, which function that we're talking about?
X squared plus 2x plus 1.
Okay, x squared plus 2x plus 1. And limit of x approaching to 0 from right. and it of course goes
X
to
plus 1.
x plus 1. Okay, now class, when x approaching to 0, it's not that x exactly equal to 0. When x approaching to 0 from left or right, it doesn't mean that it's not that x equal to 0. It's just the value of x, 0 here from -1 and 1, very close. Let's say we just imagine that this is negative 0.01 and here is 0.01, something like that. Okay, but then because of in this calculation, we just assuming, kita cuma andaikan sahaja. So when x approaching to 0 from left, the function is x squared plus 2x plus 1. Okay, substitute x with 0. 0 squared plus 2 times 0 plus 1 equal to 1. X approaching to 0 from right. Substitute with 0 plus 1, which is also equal to 1. Okay, now limit x approaching to 0 from left exists equal to 1. Limit x approaching to 0 from right also exists equal to 1. So limit of x approaching to 0 of this function fx, okay, exists. Okay, class. This is condition of limit. Limit first, not continuity yet. Okay, belum selanjar lagi, baru had ataupun limit sahaja. Okay, now we add with another condition. When x is exactly equal to 0. When x exactly equal to 0, x greater than or equal to 0, x exactly equal to 0. And this equal belongs to the function of x plus 1. So f0 equal to 0 plus 1, which is also equal to 1. So now class, the limit exists where the limit is equal to 1. And when x exactly equal to 0 is also equal to 1, 1 and 1. So what is our conclusion then? Fx is continuous at x equal to 0. Itu je syarat dia. Limit kiri dan kanan sama, wujud sama. And then when x exactly equal to that value is also the same value, then the function is continuous at x equal to 0. That's it. Okay. Okay, the second graph here. Okay. 1 over 3x minus 6 and 0. X equal to 2. 1 over 3x minus 6. Okay, the function of this fx equal to 1 over 3x minus 6, where x is not equal to 2, and 0 for x equal to 2. So class, again, 3x minus 6, denominator cannot be equal to 0, so x cannot be equal to 2 here. Okay. So now class, which I think that from this graph we know it is reciprocal. Okay, x equal to 2. The graph might be something like this. Okay, x approaching to 2 from left and also x approaching to 2 from right. Okay, limit of x approaching to 2 from left, 1 over 3x minus 6. Limit of x approaching to 2 from right, 1 over 3x minus 6. Okay, class, just give me any value of x approaching to 2 from left. From 0, 1, 1.5, 1.7, 1.8, 1.9, 1.99. Okay, 1.99. X approaching to 2 from right. From 5, 4, 3, 2.5, 2.3, 2.2, 2.1, 2.01. Let's say 2.01. Okay, substitute with 1.99 here. Class, substitute with 1.99 here.
Negative infinity.
Negative infinity. And this one, x approaching to 2 from right, 2.01.
Positive.
Positive.
Positive infinity. Meaning that the graph might be something like this. Mungkin macam ni. Okay. Okay. Does these two graph from left hand side of 2 moving to one direction, bergerak ke arah yang sama ke? Class, these two graph on left side and right side of this x equal to 2, do they move to the one direction, to the top or bottom, ke atas ke bawah, dia bergerak satu arah yang sama ke?
Tak.
No.
Tidak.
Exactly. Okay, clearly it's not because direction negative and positive. Adakah dia akan bersambung?
Tak.
Okay,
Tidak.
tak. 1 over 3x minus 6 does not exist. So if syarat pertama saja, syarat untuk limit does not exist, is it continuous? Of course not. Here you go. Okay. Limit does not exist, so therefore it's not continuous at x equal to 2. Class, what is the function of this? Can somebody read it for me? Okay. Kx square minus 2 for x greater than 1 and 2 minus x for x less than or equal to 1. Class, is this a function of this? Ya, betul eh? Class, grand function betul ke?
Betul.
Betul, sir.
Betul.
Betul, betul.
Okay, okay. Okay, now class, x greater than 1, x less than or equal to 1. So this is kx square minus 2 and this is 2 minus x. Okay. By graphically, kalau kamu nak lakarkan graf, tak ada masalah. But then to me, without the graph, if the question did not ask any graph, if the question did not ask you to sketch the graph, don't waste your time. Okay. Because from here, when x approaching to x approaching to 1 from left, x approaching to 1 from right, okay, we can just simply refer to this. X greater than 1 is for kx square minus 2 and this one is for 2 minus x. So limit of x approaching to 1 from left. X approaching to 1 from left is for the function of 2 minus x. And the limit of x approaching to 1 from right, this one here is for kx square minus 2. And the value of k, if fx is continuous, dia dah bagi syarat, dia dah bagi hints dah. Find the value of k if fx is continuous. If fx is continuous, meaning that the limit exists. The limit from left and right exists and they are equal. So limit x approaching to 1 from left, limit x approaching to 1 from right, they are equal. So then substitute x equal to 1 here and also here. 2 minus 1 equal to k1 square minus 2. So 2 minus 1 equal to 1. Then 1 square is 1 times k minus 2 equal to 1. Then k equal to 3. Syarat untuk selanjar, limit wujud dan sama. So we just use the rules of the condition of limit is enough to find out the value of k. Okay. Find the value of k for this, and h is continuous. This function of h is continuous at x equal to k. So guys, girls, okay, look at this. X, okay, for this function, x squared minus k squared divided by x minus k equal, okay, and then for x not equal to k and equal to 6 when x equal to k. And this is continuous. So class, meaning that this function and this value of y, dia bersambung. But then we have no idea what is the value of k here. So then limit of x approaching to k from left, x approaching to k from left. Okay, for this blue ink is for, okay, the blue ink is for x squared minus k squared divided by x minus k. And then for the purple ink, for the purple inside is value of y which is equal to 6. X equal to 6. Okay, so now to simplify this, x approaching to k from left equal, okay, x squared minus k squared divided by x minus k, we can simply make it equal to 6. Okay, this one is limit of x approaching to k, x minus k, and x plus k divided by x minus k equal to 6. Clear this and this. And then substitute x with k here. Substitute x with k. K plus k equal to 6. 2k. Then k equal to 3. Okay. There you go. Okay. Because we simplified this. X minus k and x plus k divided by x minus k. So then this one here now equal x plus k, and substitute x with the value of k here. K plus k equal to 6, then 2k, k equal to 3. Okay, so now class, we have 3 domains here, 1, 2, and 3. So if I make a number line here, 3 and 5, x less than or equal to 3, x in between 3 until 5, and x greater than or equal to 5. So if I make a number line here, and then stated 1, x less than equal to 3, ax squared plus 2. For this, bx plus 1, and here equal to 4. So what is the question here now? Find the values of a and b if f continuous, x equal to 3 and x equal to 5. So now class, limit x approaching to 3 from left and limit x approaching to 3 from right. X approaching to 3 from left. The k belong to the function of ax squared plus 2 equal to limit of x approaching to 3 from right, x approaching to 3 from right, and belongs to the function of bx plus 1. So substitute the value of x equal to 3 into x here. Okay, we got, okay, x equal to 3, 3 square equal to 9, 9a plus 2 equal to 3b plus 1. Equation 1. Okay, and then limit of x approaching to 3, okay, to 5 from left, x approaching to 5 from left, and x approaching to 5 from right. This is, okay, x approaching to 5 from left belong to bx plus 1. And x approaching to 5 from right belong to 4. So substitute 5 into this x, 5b plus 1 equal to 4. Then 5b equal to positive 1, bring to side become negative. So 4 minus 1 equal to 3. So then b equal to 3 over 5. So what about value of a? Substitute b into this b here. 9a plus 2 equal to 3 over 5. plus 1. 9 over 5 plus 5 over 5 equal to 9 plus 5 is 14 over 5. Okay. Minus 2. Minus 2 or 10 over 5. So 14 over 5 minus 10 over 5, which is 4 over 5. Okay. 9a equal to 4 over 5. Then a equal to 4 over 5 divided by 9 or times 1 over 9. This is 4 over 45. Is that it? Let double check. 9a minus 3b equal to negative 1. B is 3 over 5? Yes. B equal to 3 over 5 and A is 4 over 45. Saya tengok nombor ni besar sangat, takut jawapan saya salah. Okay, by the way, is correct, the correct one. Okay, A equal to 4 over 45 and B is 3 over 5. Okay, class. So exercise, look at the exercise of this last final topic. Officially, I declare that we have discussed, okay, finally discussed, we call lecture topic of 8. So then by tomorrow, 8 morning in DK4, get ready with your lecture notes of topic 9, differentiation. Okay, any question from any of you?
Yes, sir.
Kelas, saya ada share ke nota kuliah tadi? Kelas, saya ada share ke apa kita bincang tadi?
Ada.
Ada? Kenapa saya tengok macam saya tak share apa-apa?
Sekarang tak ada.
Yang saya bincang daripada awal tadi apa? Yang saya bincang baru yang baru tadi, part 4, ada saya tunjukkan dia punya nota kuliah dia?
Ada, sir.
Ada. Sebab saya tengok sekarang ni tak ada, saya takut saya tersebang seorang-seorang short sendiri. Itu saya takut tu. Yang saya bincang baru tadi pun ada ya?
Ya, ada.
Okay, ada. Okay, so guys, girls, that's all. Thank you very much for your time, for your cooperation. And kita jumpa lagi pagi esok untuk topik 9, topik 9. So take a rest. So we meet again by tomorrow. That's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day. Okay.
Thank you, sir.
Thank
Okay.
you.
Thank you, sir.
Thank you, sir.
Welcome.
Thank you, sir.
Okay. Okay, rehat malam ni.
Good night, sir.
Alright.